Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we are going to build our very own CAM scanner application. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding the problem statement and the workflow that goes along with it. Moving ahead, I'll be talking about the tools and frameworks that we're going to use to build our application. And finally, we'll end this session by giving a hands-on demo on building our application over here. Guys, before we begin, please do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're someone who's looking forward for deep learning certification using TensorFlow, please check out the link given in the description box below. Alright then, coming back to our project, right? Here, the main agenda is to build an application such that for any given image, our code should automatically detect the edges and eliminate the unnecessary part of the image while retaining and enhancing the readability of our text document. This, I would say, is something similar to what Adobe Scanner or any other scanner on your phone would do. So by the end of this project, right, you'll be able to understand the basic steps that are involved in pre-processing our image and how it can be done easily using OpenCV framework. Alright guys, so now you might be wondering, how does this project work, right? Well, let me tell you, this project is majorly towards pre-processing of our image using OpenCV. We'll not try to build any model over here or try to train anything over here. All we're going to do is, using different libraries and different frameworks and some mathematical equation for any given image, we are going to try to extract the different boundaries, that is edge detection. And once we are done with that, we'll try to get the contour and extract that contour from our image. And finally, we'll project whatever image that we have received onto the screen. All right. So let me move ahead and talk to you about some of the tools and frameworks that we are going to use. As I mentioned earlier, here we won't be training our model, as everything is pretty simple and straightforward and does not require huge amount of compute power. All we're going to do is use a simple Jupyter notebook on a system and try to see how we can enhance and build this application. So the tools that I'm going to use, like the code editor I'm trying to use over here, is going to be the Jupyter notebook, and I've created my virtual environment using Anaconda over here. And apart from that, the frameworks that I'm going to use is going to be NumPy, Matplotlib for plotting our image, and then finally OpenCV2 or Python CV, which is basically used for computer vision applications. Alright guys, so let me now quickly move to my code editor and show you how we can work on this particular application. So let me move to my Jupyter notebook here. Okay, so as you can see, our notebook is empty. Let's try to do something. Let's try to create a new Jupyter file. And whenever I do that, we would get this over here. Let me refresh this. So as you can see, we are getting this file. We'll try to change this to Python projects, or we can also say it as CAM scanner. All right, so let's rename this and we are over here. Okay, so let me zoom in a bit just so that it's easier for you guys to see. All right, fine. So to start off, we are going to import some libraries here. Get or import. Okay, so first off, we're going to have import NumPy as NP. Then I'll also import some Matplotlib. Import Matplotlib dot pyplot as PLT. And finally, we'll also import CV2. Import CV2. Okay, and we'll also import this Jupyter notebook code. Okay, that is Matplotlib inline. So let's now execute this code here. It looks great. Okay, so now first off, we need to have an image. Let's say image name would be IMPath. And this would be, we're supposed to give a path to an image. We'll add the image later. And then we'll have image img. Let's give a comment. Read image from path. So for this, we'll have image img. This will be cv2.imread. And we are just going to pass the path. So it will be im_path. Okay, let's do one thing. Let's download the image as well. Let me quickly go to my Google. Let's take some bill over here, right? So restaurant bill. And let's get down to the images here. And let's take an image where there is, huge amount of background, right? So yeah, I guess we can make use of this image here. Or let's take something. Okay, so let's consider this image, but this also has some writings here. I want something pretty, yeah, I think this looks great, right? So we'll take this and I'll save this as over here. Okay, so as you can see, I have this image. Let me copy the path here. So now if I have to read this image, all I need to do is write a dot, and if you need the recommendation, you can just put here build.jpg. Okay, let's try running this. Okay, this means that the image is running fine. So we'll write here print img.shape. So as you can see, this is the shape of our image. And now what we'll do is, we all know OpenCV reads from BGR format, and we have to convert this to BGR to gray to RGB, right? Okay, so in order to convert that, we can use the built-in function. But before that, let's also try to resize of image. Okay, so it'll be image resize, right? So resizing the image, img is equal to cv2 dot resize. Give the image that you want to resize, that is this over here. And let's say we want to resize this to somewhere around 1500 and 800. Let's see if this thing works, or else we can have an image to a smaller size. Let's try to print the image size over here. Okay, and we'll also print the image size over here. So initially you can see this was our image size, and now we have tried to reshape this up. Okay, and if you're someone who wants to see how this image would look like, so we'll have plt.imread or imshow, pass the image, and then plt.show. So as you can see, this is our image over here. I think it's better if we can take another image. The reason is because this part is kind of horizontal, right? So let me see if we can check out any other image. Okay, this image looks fine. So we'll copy this up. Okay, let's load another image instead of Bill. Let me put it as this one here. So yeah, so now our agenda over here is to crop rest of this blue part and retain just the white one, right? And we have also tried to resize the image. That is, now we have increased the size. All right, and now we have to pre-process our image, right? So there are a couple of steps that we need to perform when you're trying to pre-process our image. So let me quickly show you that. First off, what we need to do is blur the image. That is to remove the noise, and we do this by blurring our image. Okay, then we have to perform edge detection, and the next stage over here is to perform contour extraction. And then moving on, then we have to take the best contour selection. So we'll say best contour selection. All right, and then we have to project whatever output we have to the screen, right? So project to the screen. Okay, this looks great. So these are the steps. Let's perform them one by one. Okay, the first step over here is to remove the noise. So how do you remove the noise? In order for you to remove the noise, we have to perform blurring the image. We have to blur our image, right? So image blurring. Let's say this is my original image. So org, this would be image.copy. All right, now we'll convert our image into a grayscale, right? So we'll say gray. This should be equal to cv2.cvt color. So now we are supposed to pass our image. So we'll give here as origin. So org, and then we have this another function here called as cv2.color. And now what we're going to do is BGR, right? So BGR to gray. So it's BGR to gray. And let's now see how this would look like. So plt.show, this should be lowercase, imshow gray. And then we have plt.show. Let's execute this so far. So as you can see, we have got this greenish color. The reason is because we have to add a CMap. So let's say CMap is equal to gray. So as you can see over here, we have successfully converted this thing to gray color, right? Fine. So in the next stage, what we're going to do is we're going to perform a blurring. Okay, the reason why we do the blurring is because in order to remove the noise, right? So we'll say blurred is equal to, and the blurring that we're going to use over here is Gaussian blurring. So Gaussian blur, we'll just pass the name of the image. So it's going to be gray. We'll pass the filter size here, 5,5, and then we also have to pass 0. And now let's see how this blur image would look like. It's going to be the same code. So instead of gray, it's going to be blurred over here. And let's try to run this. Let me remove the CMap is equal to gray here. Okay, so as you can see, right, there's not much of difference. Let me also try removing this. Let's see what happens. Okay, if you can see here a bit closely, right, the image sharpness has decreased over here. And we can also add CMap is binary, right? And then similarly, let's add CMap binary over here. So the sharpness of, if you look closely, right, like if I zoom in a bit, you will see the sharpness of an image has dramatically reduced, especially over here for the text, right? So this is what happens when we try to reduce or when you try to add a blur. So now that we have blurred our image, what we're going to do now is convert this blurred image back to our BGR. So let's say regenerated image, right? So it will be regenerated. This would be cv2.cvt color. And now we are going to pass the name of our variable here, this blurred image. So it will be blurred. And now we have cv2.color gray to binary to BGR. All right. And now all we need to do is see the image, plt.imshow. Let's say we have origin, right? So we have not altered this. Let me copy this and paste over here. This is my origin image, and then it will be plt.show. And finally, we also have to see the regenerated image. Let me copy this and add this regenerated. Now let's see how each of these images would look like. So as you can see here, this is the original image, and this image below, you can see there's a difference, right? So if you want to see the shape of this, let's see what's the shape. So regenerated.shape. So as you can see here, although this image is no more a binary image or the grayscale image, okay, with this 3-channel, right, we can see that we have successfully converted this into a BGR. So it's no more a gray. Whatever image we're having here is a result of the blur. Okay. And now moving on, what we'll do is we'll try to perform edge detection. Okay, so let me give this in here. Let's give it a code itself. We'll say edge detection. Edge detection over here is the second stage. So we'll say here as edge. This would be CV2. The edge detection that I'm going to use over here is canny edge detection. So we have canny. We have passed the blurred image. And then we'll pass 0 and 50. Okay. And now what we'll do here is, let's say original edged is equal to edge.copy. Okay. The reason why I'm doing this is just so that, we can use this in our future. And now similar to that, all we need to do is, let's see how our image would look like after performing the edge detection. Instead of region, it's going to be original edge. And let's execute this. And as you can see here, we have successfully extracted the edges over here. Okay. So this was the original image. Then this is what we have received after blurring it. And this is what happens when I try to perform edge detection. So if you want me to add a title here, so it will be plt.title edge detection. So this is for the edge detection. All right, so this looks great. So now what we're going to do is we are going to perform contour extraction. All right, so let me give a comment here. Let's say contour. Okay, so CV2 has this built-in function that is cv2.find contours. And if you're someone who's curious to know what does this function do, if you can just type this way, right, like the function with a question mark, you will get to know its documentation. So what we're going to do here is pass an image, and then we have this mode. Okay, and then we can see the contours and different parameters that we can pass. And so most of the times what happens is you'll have a example over here that for which you can take a reference off about. So what this contour detection function does is that it basically works on a binary images, and using this we can analyze the shape, and it's usually helpful in object detection and recognition. Okay, so as you can see, this is our binary image. For our binary image, we have extracted the edges, and now we are trying to get the contours. Okay, so we'll say edge. So this is going to be this part here, edge. And then now we'll give a mode that is cv2 dot, now we have ret list. Okay, and then we'll also have cv2 dot chain approximate noise. So it will be chain approx noise. And what this would return is 3 parameters, but we are interested only in contours, right? So the first one is of no use to us. Then we have contours. So let's say COUNTOURS. And then we also don't need the third one, and this is equal to that. Okay, so this looks great. Okay, let's see what we are having an issue. Alright guys, so as you can see here, we are getting this error, right? Not enough values to unpack, expected 3 got 2. So the reason I'm getting this is because I have added this here. So let me just change that up. So as you can see, there's no more error. Let's print the length, right? So let's see what is this contours. And if I execute this, so this is basically an array, right? So this is basically telling me the points. Okay, so now let's see how many of these points I have. So for that, I'm gonna have print length of contours, and I have 396. All right, so apart from this, let's sort them up in order. So I have contours, this will be equal to sorted. We're supposed to sort contours, so let me add this over here. Reverse is equal to true because we want this string to be in an ascending order. And then key over here will be cv2 dot contour area. All right, so yeah, this looks good. All right, so now what we'll do is we'll select the best contours over here. Okay, select the best contours. So for this, for C in contours, so this will be COUN, and we'll hit tab. Okay, we all know this is an array, so this would be P is equal to cv2 dot arc length, and now we'll pass C, that is the point, and then true. Okay, and then we'll have approx. This will be cv2 dot approx for a dp, and here we're going to pass C, that is the contour area, then 0.02 times P, and here again will be 2. All right, and now what we're going to do is if length of approximation is equal to 4, then target is equal to approx. All right, and then finally take that up. All right, so now what we're going to do is we'll print just the target, right? So print target dot shape. Let me scroll this up and give a proper indentation. Target dot shape. Okay, as you can see here, I've done a small typo, so this is going to be rox, and yeah, so as you can see here, we have 4 comma 1 comma 2. 4 is because we have 2, we have 4 over here, and 1 and 2 over here. All right, so now what we'll do is we'll finally try to reorder our target, and these 2 over here are the best contours that we have received. Okay, so now we'll reorder the target contours. Reorder contours, def reorder of h, and h over here we're going to just pass the target value. Okay, and now h is equal to h dot reshape. We'll reshape this to 4 comma 2, and then we'll also print h. So what this h would return me are the coordinates, right? Apart from this, we'll have h new. This should be equal to np dot zeros. Okay, and now we'll pass 4 comma 2 here. D type, this would be np dot float, or you can also write it as like float in string. So float, we'll go with float 32. Okay, and now finally we'll add this. So add h dot sum, and we'll give axis as column because we want it across the column, right? So axis is equal to 1. Finally, we'll go down for the coordinates. H new of 3 is equal to h of np dot argmax of add. Okay, and similarly we'll do this for h new of 1, and this would just be the same. Let me copy this and paste it over here. Okay, and this is basically I'm trying to do x and y, and now we'll have the difference. So dif is equal to np dot difference. Here I'm going to pass h, and axis again will be column, so axis is equal to 1. And now what we're going to do is it's exactly similar to this. All we need to do is just change the values. So instead of 3, this will be 0, and this would be 2 again here, and here we are just going to add here def. All right, so let me just give you a brief up. So h over here basically refers to the contour that we have received, and then we'll try to create empty NP array or NP arrays of zeros of this size. Okay, 4 comma 2. And now what we're going to do is we obviously have to add the values, right? So we'll update this h new to this particular value, and this matrix we are going to return this, return h new, and let's execute this. Okay, so this is reorder the target control, and now what we'll do is we'll just say have a variable here, reorder, and let's say reorder, and we'll just pass here target. Okay, and let's say print this value and print reorder, and let's execute this up. So as you can see here, we have reordered our regions. All right, so now what we are trying to do is we'll take this target regions, okay, that is whatever this part we have find, right, contour finds, whatever the regions we have find. What we'll do is we'll map this across the image, that is our bill image, this one, and let's see how that would look like. So for that, like for this, I'll give a comment here, project it to the fixed screen, right? So project to a fixed screen. All right, so let's say input representation, and this would be reorder. Okay, and now here we'll have output map, and this would be np.float, and we'll just pass float 32 here, and this would basically be an array inside it, which I have 0, 0, then I have 800, 0, then I have 800, 800. This is totally your choice. You can give whatever you want, 800, 800, and then this is 0, 800. And if you're wondering where I'm getting this, all of these points are from this part over here. Okay, so now that we are done with this, let me execute this, and we'll have m, which is equal to cv2 dot get perspective transform, right? So we'll have perspective transform, and then we have input representation, that is this part over here, which is a reorder basically, and then this would return as an output map. All right, and now we'll have final one, ans is equal to cv2 dot wrap perspective. We'll have origin, okay, which is our original image, and then we have m, which is basically a mask, and let's give here as 800, 800, right? 800, 800. And now finally we'll try to plot this up, this ans over here. Let me copy this part from here and add it over here. So the only thing that is going to change now is the value, that is ans, and let's execute this. Let's see what this would give me. Okay, so this is giving me certain values, right? So this is not what we are expecting over here. So let's see where we are going wrong. So what's happening over here is this is giving me this particular portion over here, right? So we'll fix that up in a while. We'll try using, we'll try to rerun this from the start and fix that up. Or what we'll do is let's try rerunning this from the start. Let me just rerun this. So to do that, we'll just come down to kernel, restart and run all. It would give me this warning here, and all you need to do is restart and run all cells. So let's now see what happens. So what I'm expecting over here is, my image, whatever I have loaded over here, that is the image of the bill, I want this to crop out, right? So this is what happens when I'm trying to work with cam scanner, right? So no matter what angle you have, you try to crop it, and then you give a proper alignment there. So let's see whether we have done that right. So as you can see here, we are finally getting the output, and only the part which is required for us is present over here, and even the alignment has been done. So in order to give a better look and feel of a cam scanner application, let's try to convert this into grayscale, and also try denoising this as well. So let me zoom out a bit. So to do that, let's say final result res, let's say cv2.cvt color, and now I'm going to pass this value, that is the answer, this one, and then we have to convert this from binary to gray, right? So we have cv2 dot color bgr to gray, and now we can just print out this thing. So for this we have plt dot imshow, and now all you need to do is just pass here res and then plt dot show. Let's execute this. So as you can see, we are getting this wrong color combination. So for that we have to add cmap. So cmap, let's say, is gray. You can add gray, or you can also add binary. So it's gray here, and let's execute this. So as you can see here, it's giving us the same color. But if I try to bring this to binary here, as you can see now, the colors have been inverted up. And if you want to try to denoise this, we also have that option. So we just have to pass a filter, let's say Gaussian blur. So let's say temporary, or you can also give denoise. In a ways, it's up to you. Blur result res. Here we have something called as cv2 dot Gaussian blur. Here we are gonna pass this value, the grayscale one. Let's give this filter size 3x3 and 0 over here. And now I want to print this as well, right? So for that, let's try doing that. Instead of res, all I'll do is have this replaced over here, and let's execute this. Although you won't find any changes, if you look as a whole, but if I have to nitpick things, let me zoom in a bit. Let's see if we can find out any changes. Okay, well, I feel that this image, the second image, is more sharper compared to the one which is over here. Okay, so basically if I try to blur things out, it's basically helps us in denoising stuff. So with this, you guys can make up a simple cam scanner. And what is the future scope of this? You can actually build a mobile application wherein you can take up any image and kind of perform this operation over here. This is a simple operation that we have seen. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in a comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!